In this video, we are going to focus on rational exponents. Up to now, we focused on expressions where the variable was in the exponent. In this video, we're going to focus on variables in the base, where the exponents are rational numbers and mostly fractions. So here we will be testing whether you can remember the basic principles of adding and multiplying fractions. Example 1. Simplify without the use of a calculator. In many of your calculations, there will be constant values that we want you to simplify without using your calculator because we want to test whether you can apply the exponential laws. So when simplifying constant values, you will write the base in terms of prime factors. So in this case, 81 will become 3 to the power of 4. And now you can use your exponential law for raising a power to another power. And that says you can multiply those two exponents. Here we have 4 multiplied by a quarter, and that will give us an exponent of 1, which means the final answer is 3. In example B, we now also have variables, but the coefficient or the constant in front should still be rewritten in terms of prime factors. Now I can apply the exponent of a quarter to each of the bases inside the bracket, and again we will have 2 to the power of 1. For the x, when I multiply 3 by a quarter, I'll have 3 quarters. This should still be multiplied by x to the power of a quarter. For these two x's, when I multiply the same base, I add the two exponents, and 3 quarters plus a quarter gives me 4 quarters, or you could have immediately simplified to x to the power of 1. In example C, we once again have constants as well as variables, and I'm going to start off by rewriting the 9 as 3 to the power of 2. Next, I will be changing the negative exponent to a positive exponent by moving the whole base and exponent to the denominator. Next, I'll get rid of the brackets by applying the exponent on the outside to both the bases on the inside. So in the numerator, we will have 3 to the power of 1 times x to the power of 3 over 2. And in the denominator, we will do the same. So we will have 3 to the power of 2 times x to the power of 1 multiplied by x to the power of a half. Now we can simplify the 3 to the power of 1 divided by 3 squared by subtracting the exponents. And because there were more 3's in the denominator, the 3 to the power of 1 that is left will be in the denominator. Next up, I will simplify the x values in the denominator by adding the exponents. And when I have 1 plus a half, I'll have 1 and a half, or 3 over 2. And my final simplification will be to say that x to the power of 3 over 2 divided by itself is 1, and my final answer will be a third. Next, let's have a look at equations with rational exponents. In example 2, we are asked to solve x, and we have x to the power of a third equals 4. You should already be aware that x to the power of a third can be rewritten as the cube root of x. And to now get rid of the cube root, I'm going to do the inverse operation, which is to raise to the power of 3. But because this is an equation, I need to repeat everything that was done on the left on the right-hand side. Because the cube root and cube are inverse calculations, on the left-hand side we'll be left with only x. On the right-hand side we have 4 cubed, which is 64. If you did not know that x to the power of a third is the cube root of x, you could have followed the exact same steps and also raised to the power of 3. If you raise to the power of 3 on the left, you of course still repeat that on the right. Now you can use your exponential law and multiply the two exponents, and when you multiply, you will end up with x to the power of 1 and still get the same answer. So, when you want to solve a variable that has a rational exponent, specifically a fraction, you can simply raise to the reciprocal of that exponent. The reciprocal is the swapped around fraction, and that fraction will always cause you to end up with 1 when you multiply the two exponents. In example B, we once again have a rational exponent, but this time we first need to get rid of the coefficient of 2. To do that, we're going to divide both sides by 2 and end with x to the power of 7 over 6 equals to 128. Now we can raise to the reciprocal, as I just mentioned, and here the reciprocal of 7 over 6 will be 6 over 7. And this needs to be repeated on the right-hand side. Now it is important to show all your steps. On the left-hand side, we can simplify to x to the power of 1, but on the right-hand side, you first have to change that 128 to 2 to the power of 7. Now I can simplify that 2 to the power of 7 to the power of 6 over 7, and I do that by multiplying the exponents and getting 6. This, of course, is 64. In example C, we now have a trinomial. So it's important for you to realize that you can also do trinomial factorization with rational exponents. Firstly, I'm going to show you how to do this using the K method. And for that, you need to realize that x to the power of a half can be rewritten as x to the power of a quarter to the power of 2. Because when I multiply these exponents, I get 2 over 4, which can be simplified to a half. Therefore, my first step will be to write x to the power of a quarter to the power of 2 minus the 7x to the power of a quarter plus 12 equal to 0. Now, just for the moment, I'm going to substitute x to the power of a quarter with a k. Because when I do that, I have k squared minus 7k plus 12, which is a normal trinomial that I can factorize. This means we know that k is equal to 3, or k can be equal to 4. Now I can change k back to x to the power of a quarter. To solve x, I will then raise to the power of 4 on the left and the right hand side to get x is equal to 81. Similarly, on the other side, I will raise to the power of 4 and x is 256. This calculation can also be done without using the K method. As soon as the exponent of the first term is halved to get the exponent of the second term, I can always use trinomial factorization. When applying that trinomial factorization, it is then important to remember that the exponents in these two brackets will always be the middle term exponent, which is a quarter. And now we can factorize as normal. So we focus on the factors of the plus 12, and minus 3 minus 4 will give me the middle term of minus 7. Now I can directly say that x to the power of a quarter can be equal to 3, or x to the power of a quarter can be equal to 4, and then I follow the same two last steps.